Hello everyone, hope you are all doing fine. In this video, I want us to look at these two implicit functions. Now the instruction is that find y dx in terms of x and y for the following curves. So these two are equations of curves and they are under implicit functions. Now implicit functions are functions where we cannot express y in terms of x, or we cannot make y as the subject of the formula. Just look at the first one here. Xy plus y square equal to x. So we cannot completely factor out y to make it as the subject of the formula. For explicit functions, this is where we have y expressed in terms of x. And for this one, it is very easy to find dy dx. So now, how do we get dy dx of such functions? So starting with the first one, xy plus y square equal to x. Xy plus y square equal to x. So how do we get the derivative of this function? So we are going to apply differentiation to each of these terms, okay? And this will be with respect to x. So for the first one, I'll show it like this. d dx xy plus d dx of y square then equal to d dx of x. So we want to find the derivative of each of these terms with respect to x. So now for the first one here, we've got these two variables multiplying, and what this means is that we are going to apply product rule on this one. So for the first one, we are going to keep x constant. So keeping x constant, finding the derivative of y gives, first of all, x is constant. Finding the derivative of y will give us dy dx. So whenever you are differentiating y, you get dy dx. Then, keeping y constant, finding the derivative of x. The derivative of x is just 1. So 1 times the y that we kept gives us y. So the derivative of x, keeping y constant, is just going to give us y. Then going to the second term here, let's get the derivative of y square with respect to x. So this is going to give us 2y. Okay, so this power will multiply with the coefficient there to give us 2. Then y, this is because 2 take away 1 gives us 1. And y to the power 1 is just simply y. But we say that the derivative of y, okay, finding the derivative of y with respect to x gives us dy dx. So for this part, we also get dy dx. This is equal to, what is the derivative of x? So derivative of x is just simply 1. So on this part, we are getting equal to 1. Now, when we get this form, we just have to now collect all the terms with the dy dx. And then for this term here, we are going to take it to the right side. So now, collecting all the terms with the dy dx, so this means that here we're going to have x dy dx, then plus 2y dy dx. All this equal to 1 minus y. So this is because when this crosses over to the other side, to become a negative. And then here we are going to factor out dy dx. So I'll show it on top here. Factoring out dy dx gives us the following. So for the first term, we are going to remain with the x, so x. Then plus, for the second term, we are going to remain with 2y. If we factor out dy dx, and this is going to equal to 1 minus y. To get dy dx, we divide by x plus 2y. So divide by x plus 2y, both sides. This simplifies with this to give us 1 here. And 1 times dy dx will give us dy dx. equal to 1 minus y over x plus 2y. And this here is the final answer for the first part. So finding the derivative of xy plus y square equal to x gives us dy dx equal to 1 minus y over x plus 2y. So that is for the first part. Then for the next part, what we have is for b, we have 2x squared minus 3y squared equal to 2x plus 3y minus 1. So for this one, we are going to work it out like this. To find the derivative of this function, we do the same thing like we did on this one, where we apply differentiation on each of the terms given. So what is the derivative of 2x squared with respect to x? So this will give us 4. 2 times 2 gives 4x, because 2 minus 1 will give us 1, and x to the power 1 is just simply x. So this will give us 4x. Then minus the derivative of 3y squared. So 2 will multiply with 3 to give us 6. And then 2 take away 1 will give us 1. And y to the power 1 is just simply the same as y here. Now the derivative of this one, 3y squared, gives dy dx. So on this one, we are going to write dy dx. So whenever you find the derivative of y, you also have to introduce dy dx. So this is equal to derivative of 2x is just simply 2 here. And then the derivative of 3y. So since there's y, so we are going to have the following: 3, then dy dx. Then the derivative of negative 1 is just simply 0. So we are not going to show it on this part. So then, what do we do next? So what we're going to do is collect all the terms with the dy dx on one side. So we can do it this way. For example, I'll move 2 to the left side, and I'll move this term, negative 6y dy dx, to the right side. So this will give me the following: 4x minus 2 equal to, I can start with 3. So 3 dy dx, then plus. When this moves, it becomes plus. So plus 6y dy dx. Then factoring out dy dx on the right side here will give us the following. So factoring out dy dx will give us the following. So for the first term, we are going to remain with the 3. So 3, then plus. The second term will remain with the 6y. Then on the left side here, we have 4x minus 2. So what we just need to do now is divide through by 3 plus 6y to get dy dx. So dividing through by 3 plus 6y both sides. 3 plus 6y. 3 plus 6y and 3 plus 6y. This side simplifies to give us 1. 1 times dy dx will give us dy dx. And then this side will maintain what we have. So we just have to swap. We'll start with the dy dx. So this will be dy dx is equal to 4x minus 2 over 3 plus 6y. So this here is the solution for the second part B, finding the derivative of implicit functions. So we've come to the end of this video. Thank you so much for watching this video. Look out for more videos in additional mathematics.